trying to decide which approach to take first. Let's go the functions route just for a second. Talking notation for a second here. If I wrote something like this, it's a particularly boring something that I wrote, but I would read this as saying the limit as x approaches 3 of x squared minus 4. That's a whole lot of words for a question that's really asking us, what is the y value getting close to? As the x value gets close to 3. Now, the reason that I started with this is we already know how to find y values. If I have the equation of a function, I find the y value by plugging in the x value. And it's totally fine to do that with limits, as long as the answer you get is a number. So the first step I'm always going to try with a limit problem that involves functions is to plug the number in and see what happens. So if I were to plug in 3 squared is 9. And then I can subtract 4 and I get 5, and that's done. That is the answer to the limit. No one's ever going to ask you a limit that looks like this because that's boring. At least it's boring to a mathematician. Instead, they're going to ask you questions where something goes wrong. There are a couple of ways something can go wrong. One of the most popular ways is to divide by 0. So I'm going to change our problem up a little bit. And let's say that this really was asking me the limit as x approaches 3 of x squared minus 9 over x minus 3. I'm still going to walk up to this problem and say, limits are just asking me what's the y value trying to be when x is trying to be that number. I can do that. And I can come over here and plug it in. And if I plugged it in, I'd have 3 squared minus 9 over 3 minus 3. And man, am I in trouble because I have a 0 on the bottom and a 0 on the top. Now, 0 over 0, in a previous life, you may have had an instructor that called that undefined. We're in calculus now, so 0 over 0 is secretly whispering, do some algebra. When you get 0 over 0 for a limit, that problem is telling you, go do some algebra. Now, the kinds of algebra that we're going to end up doing for a 0 over 0 limit include factoring, multiplying by the conjugate, or finding common denominators. And all three of those things are going to show up eventually. I don't want to dive a ton into the algebra because, quite frankly, I'm short on time and we've got people who are doing limits in lots of other ways. But I just wanted to throw that out there that in terms of the algebra, factoring, I promise we'll do more practice, but factoring, conjugates, we're going to spend a lot of time working on limits, folks. Don't worry. Factoring, conjugates, and common denominators are the three most common types of algebra that we're going to end up doing with limits that involve numbers. Most of you have been doing limits that involve infinity, either because you're looking at sequences and you're looking for the limit of a sequence to determine if it converges, or we're looking at limits of functions as x approaches infinity. I'm going to start in that context, and then we'll circle back around to the sequences context. But there are a couple of limits with infinity that I want to make sure we're super clear on first. So just for fun, this part probably won't make sense in your notes later. I don't actually know this. Does anyone know who the richest person in the world is? Yeah. Should we just pretend it's Bezos? Jeff Bezos? Okay, so let's just pretend it's Bezos. Okay, so from my perspective, he basically has an infinite amount of money. Does anyone know how many heirs he has? Like if Bezos dies tomorrow, who gets the money? Anyone know? Does he have kids?
He has kids. Let's say he has two.
Let's say he's got 2 kids.
Sure.
So if that basically infinite amount of money gets split between 2 kids, they still are really rich. Yeah. They basically still have an infinite amount of money. Where I'm going with this is that if I have infinity divided by a number, well, that is still infinity, folks. Now let's flip this around. I do not have my wallet with me today. I don't normally carry a lot of cash, but I think there are $11 in my wallet at the moment. So let's say that I was feeling generous and I had my $11 and I was going to share those $11 with everyone in California. Now, there are not truly an infinite number of people in California, but relative to my $11, there might as well be. If I tried to share my $11 with everyone in California, how much money does everyone get? Way less than half a cent. There are millions of people in California, and 11 divided by millions is a whole lot of zeros before you get to a number. In fact, if I have a number divided by infinity, this is headed to 0. These 2 things are really fundamental to all of the rest of the limits that we do. And it doesn't particularly matter whether these things are positive or negative numbers, in the sense that negative infinity divided by a number is still an infinite number. It's just a negative one of those infinites. But we have to address the weird one. I think these 2 are pretty logical. Infinity divided by a number, still a huge number. Something divided by infinity got really small. But here's the weird one. What if I have a number divided by 0? This one is weird. And I think doing an example and making this a little bit more concrete might be helpful. Does anyone have a favorite number? 7, sweet. I love 7s also. So I'm going to look at the limit as x approaches 0 of 7 divided by, x. Yes. We're taking a limit here. We should put the x at the bottom. 7 divided by x. Okay, so I can't really divide by 0. We've been talking about how you can't divide by 0. In a previous life, you might get to quit there. Not in calculus. In calculus, this says keep doing more work. Here's the more work we're going to have to do. And this is just to illustrate what's happening. We don't have to write this work in the future, just to illustrate what's happening. Somebody give me a number close to 0, but not quite there yet. Cool. So if I had 0.01, I'm going to go ahead and write that as a fraction. So 0.01 is 1 over 100. So if I were to think about plugging that in to this, I would have 7 divided by 1/100. And now if I use my fraction rules, that's really the same as saying 7 times 100. $700's pretty big. If I wanted to get even closer to 0, maybe I could stick a couple extra zeros in here. Maybe I could make this 0.00001. 1, 2, 3, 4, 5. So I would need a bunch of zeros there, which would give me a bunch of zeros here, which would give me a bunch of zeros here. So if I have a number divided by 0, this is actually getting really, really huge in a hurry. So a number divided by 0 is headed to infinity. And it's our job to figure out, is it headed to positive infinity or negative infinity? So I'm just going to write this as a plus or minus in kind of my like rules bank over here. And then we're going to need to talk a little bit about notation. So if I had the limit as x approaches 0 and I put in a plus right here, then what that's telling me is I'm approaching 0, but I'm going to do it from a little bit more than 0. 0 plus a little bit. Meaning, when I think about this, my top is 7. The bottom, if I plug it in, is 0, but a little bit positive. And a positive number over a positive number is headed to positive infinity. If I switched that up and instead I had 0 with a minus sign here, so I'm a little bit less than 0, then that would look like 7 divided by a negative number, and I would be headed towards negative infinity. So in general, if you get a number divided by 0, we should be thinking about infinity. But we want to be careful to think about which side are we coming from to figure out if it's a positive infinity or a negative infinity.
So if there's like a negative number on top of that, then that would determine if it's.
It'll also depend which side we're on. So like if I think about the graph of y equals 7/x, I'm going to squeeze it in up here. It's pretty small, but I got this. So this is y equals 7/x. So since the answer to a limit problem is what the y value is trying to be, if I'm starting off with something close to 0, but a little bit positive, that means I'm over here on this side of the graph. So that y value is headed up towards positive infinity. But if I were taking the limit as x approaches 0 from the left, then that would say I start on the left-hand side of 0. And if I'm kind of following the graph to see where the y value is headed, that y value is headed down to negative infinity.
Will they tell us?
So if they don't, and you get a number over 0, you should split it up and you should do the left side and the right side.
Okay.
Most of the time, they're going to tell you that it's coming from the right or it's coming from the left. Yeah. But if it's not there and you do the limit and you end up with a number over 0, you should check both. Okay. And flip the page. We're going to talk some limits to infinity. Sorry, down? How far down? Like all the natural log stuff, the old stuff? Okay. I'm going to talk some limits to infinity. And we're going to do some weird algebra for some limits to infinity. And then we're going to loop back around to talk sequences. Okay. In a previous life, you maybe took pre-calc. I hope you took pre-calc. If you didn't take pre-calc, it's okay. But in a previous life, you probably either took algebra 2 or pre-calculus at some point in time in your life and did something with horizontal asymptotes. Horizontal asymptotes fundamentally are really asking that question, what's happening way on the edges of the graph? Or what's that long-term or endpoint behavior? Well, way out on the edges of the graph, X is trying to approach positive infinity or negative infinity. So when we're looking for horizontal asymptotes, we're asking what's happening in that limit as X approaches positive infinity or negative infinity. And I'm just going to give us something gross so that we can practice some algebra. Let's say that I had the limit as X approaches infinity of, no, I'm going to make it not so gross. 2X over 1 minus 3X. From a previous life, or perhaps this quarter, does anyone already know what the answer is? We'll talk about how to show our work, but does anyone already know what the horizontal asymptote is for this one? Got a couple answers in the chat. Couple answers involving a 2 and a -3. Got some cautious guesses in the room. So the horizontal asymptote for this thing does end up being -2/3. Let's show some work to get there. In a pre-calculus or algebra 2 class, you may have had to do polynomial long division on this. We are not going down that road, folks, though you can if you want. If you're like great at polynomial long division, you absolutely can do that. Our calculus version of what we would usually do, well, the answer to a limit problem, the first thing I'm going to try is to plug it in. And when I plug infinity, I get infinity on top and a negative infinity on the bottom. Similar to 0 over 0, infinity over infinity is whispering to us, go do some algebra. The algebra we're going to do for an infinity over infinity problem is to find the largest power of X in the denominator and factor it out, even if it is weird to do so. So I'm going to take that biggest power of X in the denominator, which in this case is just X, and I'm going to factor it out from both the top and the bottom, even though it's weird. Factoring is really just undoing multiplication. So this just means, what do I have to multiply by to get back to where we started? Well, on the top, I would have to multiply by 2. And on the bottom, weirdly, I would have to multiply by 1 over X minus 3. Because if I were to distribute that X back in, I would get 1 minus 3X. The beauty of doing this is now X over X is equal to 1. So this piece is out of my way. And when I go to think about this limit, I've got 2 divided by, again, I've got an infinity over here. So 1 over infinity minus 3. And we already decided that a number divided by infinity was headed to 0. And my final answer is 2 over -3. Question.
Why do they change that X? Lost.
This one?
Yeah.
So the way that I evaluate a limit is by plugging the number in. Since I'm taking the limit as X approaches infinity, I'm plugging infinity in.
If it was like X approaches to 5,
I'd plug 5 in.
Oh,
Yep,
okay.
totally. Wherever that limit is headed. I'm going to do one more messy one. And there are other kinds of algebra that can show up here. Sometimes factoring the biggest power of x out isn't enough, and I might still have to do something with a conjugate. So if you've got square roots, sometimes we have to do a conjugate if the factoring the biggest power out doesn't work. But I'm going to do one where factoring the biggest power out does work, even though it's weird. I'm going to look at this problem. I'm going to say if I plug infinity into the top, I get infinity on top. If I plug infinity into the bottom, I also get infinity on the bottom. And infinity over infinity says, go do some work. I'm looking at the bottom and I see an x to the fourth. That's what I'm going to factor out. But I'm going to be careful about it because it's actually inside of a square root. So I'm going to factor out that x to the fourth. And I'm going to get 1 plus 1 over x to the fourth. And then I'm going to say, well, what do I get when I take the square root of x to the fourth? Totally. So I've got the limit as x approaches infinity. I've got that x squared on the top. And now I've also got an x squared on the bottom. And conveniently, my x squareds are going to cancel out again. Yep. Couple of different ways to think about it. We can think about it by switching that square root to a fraction exponent. So like if I had x to the fourth and then raised that to the 1/2 power, powers raised to powers, I'm going to multiply that, and 4 times 1/2 would get me back to 2. I think that's, for me, that's the way I think about it in my head. So my x squareds have canceled out, leaving me with a 1 on the top. And if I plug in the infinity, because that's where my limit is headed, on the bottom, I've got 1 plus 1 over infinity. Infinity to the fourth is still infinite. It's just an even bigger infinite. And 1 over infinity is again headed to 0. So I'm looking at 1.
How do you know it's headed to 0 if it's 1 over?
So if I have $1 and I split it with everyone on the planet, no one gets any money.
Okay.
That's literally the way I remember it.
Okay.
Right? That if I have a number, no matter how big that number is, if I divide it by infinity, I'm going to end up with 0. Okay, I am totally happy to do lots more limits problems with folks in office hours sometime. There was a specific request that I do want to look at this one particular limit, and then we're going to switch to talking sequences and recursive stuff. But 2 cosine 3x. Oh, I don't, yeah, that's not an infinity symbol up there. That's an X. I just couldn't read that. Okay. When I am confronted with a limit problem, I am going to plug the number in and see what happens. Well, if I plug in infinity, and this is e to the negative infinity plus 2 times cosine 3 times infinity is infinity. This limit does not exist. And the reason this limit does not exist is The answer to a limit problem, and this is looping back around to the idea of convergence of a sequence. The answer to the limit problem is the one specific y value that the graph is trying to approach. Or in a sequence, the one specific value that that sequence is approaching after a long time. Well, cosine is bouncing around forever. It never settles down to a single value. The limit for cosine is not going to converge. We don't get a value out of this. So this part does not exist. Or you could say, if this were the limit of a sequence, that diverges because I'm not settling down to a particular value. The e to the negative infinity, this one's okay. This one's headed to 0 for the same reason that 1 over infinity is. If I have e to the negative infinity, first of all, I could think about that from a graph perspective. So here's y equals e to the negative x, or sorry, this is y equals e to the x. And then if I think about what's happening as x approaches negative infinity, y is approaching a value of 0. The other way to think about it is e to the negative infinity, that negative in the exponent, I could think about being 1 over, right? So e to the negative infinity is the same as 1 over e to the positive infinity, which puts us into the 1 over infinity category, which means we're getting to be 0.